the Dataholics YouTube channel. And today we are going to create a data analytics project, right? And in which we'll be using SQL Server as well as Python, right? So overall flow of the project will be something like this. Let me explain it. So first we will take the data from Kaggle using Kaggle API. We will transfer that data into Python, right? And then load the data into pandas. We will do some basic analysis. We will understand the data. We will do some we will get some insights and solve some questions in pandas only. Then we will create a connection between Python and SQL Server, and I'll take the data from Python pandas to SQL Server. And the same data will be copied into SQL Server in a database. And then we will do same analysis, which we have already done in pandas in SQL, wherein we will be writing SQL queries and then validate our output in which we are getting into pandas as well as in SQL. Right. So overall, this project will help you to understand the concepts in Python as well as SQL Server. Also, it will help you to extract the data from Kaggle, right, which is the overall end-to-end data analytics project, right? For example, we take data from different data sources, understand the data, clean the data, do some data analysis, get some insights, and create a report, right? And at the end, we do data validation. So this is end-to-end data analytics project. It will really help you to put a good project into your resume or practice Python, SQL, understand what a data analyst do, right? So that's all about the overview of the project. And without wasting much of the time, let's get started, right? So first I will show you a method. Well, first let us see how to download the data from Kaggle into Python, right? So to download the data from Kaggle to Python, there is a prerequisite. First, we have to have the Kaggle API installed and configured with our Kaggle credentials. So what does that mean is, first we have to go to the Kaggle, right? Kaggle.com actually is a open source platform, right? Wherein we can get a lot of data sets. We can they host competitions in which we can participate and contribute also, right? So let's not get into deep that, right? So first when we open Kaggle.com, right? So if you haven't signed up, so you just need to sign up. It's completely free of cost, right? And since I have already signed up, I will just go to my account and I'll go to the settings option. In the settings, when I scroll down, we will have an option of API, right? So you have to create new token. So create new token, continue. It will download a kaggle.json file into your system, right? It will be in the downloads folder, right? So if I show you here, it's in the downloads folder, kaggle6.json. I am downloading it for the 6th time. That is why it is written 6. So then I'll just create a new folder. Let's say in this my projects folder, I'm going to create a new folder wherein I will YouTube data analytics project, right? In this folder, I'll be putting all the files and then I'll upload this on GitHub. You will get the link to this project on GitHub also, correct? So here first I will, what I will do is I will just open command prompt, CMD, right? And after this, I'll open Jupyter Notebook. So if you have, while installing Jupyter Notebook, if you have configured the to open from the path, it will open like this way. Otherwise, you can directly open from Anaconda Navigator also. So right now I'm opening Jupyter Notebook in this folder, correct? And then yeah, meanwhile, what we have to do is the Kaggle file which we have downloaded, we have to just copy it, or maybe you can cut it down, right? And you have to go to Windows C drive in that users folder, in that HP. Instead of HP, you will be having might be your name, right? So you have to go into your folder, and in that folder, you will get the option of .kaggle, right? And you have to just paste it here. I'm deleting it and pasting the new file, the kaggle6.json, right? So actually, right, it contains your username as well as the API key, right? So it is confidential. That is why I'm not showing it. But yeah, this is the way you have to download it and put it into that folder. After that, what I will do, I will just, I have already opened this Jupyter Notebook. I'll just go and create a new Python file, right? And I'll just rename the Python file to some good meaningful name. Yeah, right. So let's just get the name Data Analytics Project, correct? And I'll just create some new cells here. Right. Okay. So first, what I have to do, let me just explain it to you here, and I'll just copy the code. So we have done this step. Then after this, we have to use the below command. Like for example, in here we have to use this command: exclamation sign Kaggle datasets download. That means we are going to download some dataset from Kaggle. The dataset is uploaded by this user Akshad Agrawal 9431, which is me. and the file name is folder name is shipment orders dataset, and -f, it is specifying the file which is to be downloaded, and the file name is orders data.csv file. Correct. So this is how we can download the file, right? So you'll get this link, right, in the description, or maybe in the GitHub link, right? So this command is used to download the orders_data.csv file from the shipments order dataset hosted by Akshat9431 on Kaggle, right? So this is just an instruction to read and understand what are we doing. It typically runs in the Jupyter Notebook or any other environment that supports the shell command, wherein you can execute Python code, correct? So let me just copy this code and come here, and let's run it, right? Before doing that, we have to download, import, actually pip install Kaggle. We have to install Kaggle or library also. So we just have to install this pip install Kaggle. It will download it and install the library, and it will download this dataset. After that, meanwhile it is downloading, let us understand a few steps, right? After that, we will just, okay, so when we do that, so it will download the file into a zip file. Correct. So we have to unzip also. So to unzip that, I'm using zip file library of Python. Import zip file. I'm importing that file to use it. I'm creating an object like zip ref is equal to zip file dot zip file. Just focus, Z and F are capital, and I'm just putting the folder zip file here, and I'm writing zip underscore ref dot extract all. So it will extract all the files in that zip file. Correct, inside that zip file. And after that, I'm just closing it. Let me just copy that and paste it here. So see, we see that pip install Kaggle, it is downloaded. And then after that, I'm just downloading this data set. It is downloaded, right? And after, okay, so let me show you how it is downloaded, right? So we created just new folder right here, but see, some seconds ago, right? It is maybe download the orders_data.zip file. And if I show you here also, if you just go to YT Data Analytics project, the folder which we have already created, so it is downloaded here, right? Orders_data.csv. So what you can do, you can just download the CSV file, or from here you can import the CSV file directly from here into pandas by using read_CSV file, or else we can just unzip it first on the first hand. So let's just do that. And the file name is, see, the file name is orders_data.csv.zip, right? So I'm using the same name here also. So it's just that, right? So it is the file is extracted. If we come to the folder, you see that orders_data.csv is also imported. It's extracted a seconds ago. Correct. Then what we have to do, we have to import the data using read_csv file. So what I will just do, I will just read the CSV file into a data frame. df is equal to pd.read_csv orders_data.csv file, right? So to see the top 5 rows in the folder in the data frame, I have to use df.head. So first I have to import pandas also. Import pandas as pd, and I'm running it. So to import pandas library, and then I'm using this. So this is the top 5 rows. Let us quickly understand the data set. So this is a basically e-commerce kind of data set in which we have order ID, the order date, the shipment mode, it like secondary class or standard class or whatever, segment of the customer, consumer, corporate, or what, country from which the order was placed, city from which the order was placed, state from which the order was placed, postal code, region, and the category like furniture, office supplies, or what. Then the subcategory of the order placed, product ID, unique ID of the product, right? And then cost price of the product, listing price of the product which was listed on the product, quantity purchased in this particular order ID, and then the discount percentage, right? So this is the overall data set which we currently have, right? So then we can use some pandas function like df.shape to understand, okay, how many rows and columns are there in the data set. Okay, there are 9994 rows and 16 columns in the data set. If I also want to see the information of the data set, so right, to see the column name, to see the non-null values, count of the values, and the data type. So we can very clearly see that we have order ID, it has 9994 non-null values, right? So all of these columns have 9994 non-null values. That means there are no blank values in the data set. Correct. This is how do we understand the data. And to clean the data, we have to first understand the data. But here we see that order date, right? It is an object data type. Object data type is kind of a string data type. But we do not have to put it into object data type. We have to convert it into date data type, which we will do later on, right? And then we have, okay, right? Everything looks sorted, right? So this is how do we analyze the data, understand the data. Then also what we can do is in this here we let us I have already but because I have already understood the data, I know that in the shipment column there are some issues, right? Let us understand df.ship mode, right? So if I do that, okay, so these are the values in this column, right? But if I use the function unique, right, so it will give me all the unique values in this column. So we see that, okay, second class is a good value, standard class is a good value. There are some values called not available, unknown, first class is again good, non values, and the same day value. That is all good, but these two values look, that does not look meaningful. So it actually means that the value there was not present, not available, so it must be treated as a non value. So we can handle this while importing the data set itself. While importing the data set, if we press Shift, Tab, and Tab. So once we scroll down, we have a column, we have a value of NA underscore values, right? So by default, it considers NA values as NAN. But if I also want to consider this not available and unknown as NA values, we have to just tweak the importing code. So if I just use this, right, put it here. Now I'm reading it into df1. That is a new data. I'm creating a new data frame. pd.read csv, orders data.csv file. Okay, that's great, right? And then we have to treat and not available and unknown also as the NA values, correct? So if I do this, and after that, if I see the unique values in the column, then it is only second class, standard class, NaN, first class, same day. That's all, right? So that is how I treated not available and unknown in this here. Now we have dealt with the ship mode column, and we have updated the unique values, and the new data frame is df1, right? So if we see the top 5 rows of the df1 data frame, these are the top 5 rows, and these are the columns which we already have in the data set. Let's moving forward. All right, so we see that there are few columns like listing price and the cost price, and we also have a discount percent. So what we can do, we can calculate the discounted value, right? So what we have to do, we have to subtract listing price into discount percentage from the listing price actual value, right? So let us see. So now we are going to derive some new columns like discount, selling price, and the profit, correct? So df.head2, it will give us top 2 rows. So if we do not write 2 here, it will give us top 5 rows by default. And if I want to only see top 2 rows, I can just write 2, right? So this is the thing. Now to calculate the selling price, what we can do, we can create a new column. So see, df in single quotes, we are writing selling price. That will create a new column called selling underscore price, the equal to df list price minus df list price into df discount percent in divided by 100. So right, so here we have to make it like df1, I think, because we have got the latest data frame as df1, right? So by mistake, if I have written df somewhere, just think it as df1. So df1 dot selling price is equal to df1 listing price minus listing price into discount percentage divided by 100, right? So if I run this, so now we have calculated the selling price for each row, correct? Now if I see df1 dot head 2 here, so you will see that we already have a column for selling price here, correct? That's the thing. Now if I want to calculate the profit column, so df of profit, again it's df1 only, right? So df1 of profit is equal to df of selling price. So what is profit? Profit is equal to selling price minus cost price. So it will be simply calculated like this. df1 of profit is equal to df1 selling price minus df1 cost price. That will give us the profit value. If I run this, it will calculate the profit for each row. So here you can see some negative value. That means in this deal, we have made a loss, right? So if I want to see the top 2 columns of df1, so you will see that we have selling price, and after that selling price, we have profit also, correct? I hope that makes sense. So we see that in the df1 data frame, we have list price, quantity, discount percentage. After that, we have calculated selling price and the profit value, right? But see, these are the selling price and profit value for each product, right? For quantity 1. So now what I can do, I want to rename this column from profit to unit profit, because it is a profit for one article. So from selling price to unit selling price. So what I'm doing, I'm using a function from pandas library, that is df1.rename. It will update the column names, right? So rename in bracket, we have to write columns is equal to, and inside a dictionary, like a key value pair, we have to provide the old column name and the new column name. So old column name was profit : unit profit. Similarly, selling price colon unit selling price and in place is equal to true will make this operation permanent. That means which makes it in place is equal to true will make this change from profit to unit profit, the rename function as permanent, and it will update the df1 data frame. So after running this line, if I show you the thing, that it will be discount percentage, after that it is unit selling price, and it is unit profit. That change has been made permanent in the df1 data frame, right? After that, if I see the data types of each column, df1.d types, it will show you the data types of each column. So we see that order ID is integer, order date is equal to object. Now we have to update the data type from object to date. So changing data type of order date column from object to date time. So for that, we can very simply use pandas function, that is to underscore date time. Correct. So if I show you df1.head2 is equal to this, right? So df1 of order date. So we are changing the data type of this column. So order date is the original column. df1.order date is equal to, now update the value of this column with pd.to underscore data time df1.order date. That means this, take this column and change its format to d, m, and y, right? Date, month, and year, like this, and update the value, update the column df1.order date. After running this, if I show you the data types of each column, you will see now from initially it was object, now it is date time 64, right? And df1.head, if I show you that, the values will be like this, right? Year, month, and date. I hope that makes sense. Correct. Then we are here. I'm going to drop a few columns. Okay. So actually, why I am following these steps? So see, as a data analyst or as a business analyst, we have to figure out which column is important for us, which column is not important for the future references, right? And we can drop unnecessary columns to avoid unnecessary utilization of space storage. So I think that cost price column is not needed now, because I have already calculated that profit and the selling price and everything. So cost price, listing price, and the discount percentage, these are not needed now. And in place will make this operation again permanent. It will remove this column from df1 data frame. So df1 dot drop, again inside the bracket we have to write columns is equal to. Now we have to give all the column names. If there are multiple column names, then we have to put it into a square bracket, right? So this is what I'm going to do right now. And after that, if I run df1 dot head, let's say instead of seeing for 5 rows, I just want to see 2 rows, right? So see, product ID, quantity. After that, it is only unit selling price and unit profit. All other columns are lost, removed. Now let's if I want to calculate, so see, it is a unit profit. Now if I want to calculate the total profit, so for example, here the unit profit is 14.8 and quantity is 2. So if I have to calculate the total profit for this order, that will be 14.8 multiplied by 2. That is unit profit column multiplied by the quantity column. So df1 total profit, I'm creating a new column called total profit, which will be equal to df1 of quantity multiplied by df1 of unit price. That will give us total profit for each order. So if I run it now and show you the top 5 rows of the df1, so you will see that here we have already created total profit column. Right. So now if someone asks us to get the calculate the total profit earned by the system, then we can just take a sum of this column, total profit. I hope you are able to understand now. Now let us see how do we export the data frame to SQL Server, right? So we can also export the data from data frame to different databases like my PostgreSQL, MySQL or something. Here I'm using a SQL Alchemy library to transfer the data from a data frame to SQL Server only, right? So first I'm importing SQL Alchemy library as SAL. Then there are a few steps when we want to transfer the data from, export the data from, data frame to SQL Server. First, we have to create an engine to connect with the database actually, right? Then instead of MySQL, for example, here I'm writing MS SQL. That means Microsoft SQL Server. But if you're using another database, then we can write MySQL or PostgreSQL or whatever. Then, so see this line, engine is equal to sal.create engine. So the create engine function creates an SQL Alchemy engine object, which establishes a connection to the SQL Server database. It helps us to connect Python and SQL Server database. Then the connection string specifies the data type. So see, this is the database type, right? MS SQL. If you are using Microsoft SQL Server or MySQL or PostgreSQL, then you can use that database name. Then this is the server name, right? So if I show you MySQL Server, right? So I'm a SQL Server. So you can see to the top left, right? Laptop and dash 160 PLGFN. This is my server name. So you have to just copy that server name from your system. oblique project, right? So project is the name of my database. So here I have a database called project, and inside that I want to transfer this data, right? And this is the driver name, right? So driver name you can get from your system. So I'm creating an engine here. Then I'm creating a connection object, that is an engine object. So engine object connection will be the CON, and it will be the communication object for us to communicate with the database. So CONN connection object is equal to engine.connect, right? So this will create a connection object, and then I'm writing the main line df.to_SQL. Actually, I have to write df1 because I am going to export the data. Yeah, df1. So let me first write df1.to_SQL orders data. So this will be the table name in SQL Server. CON connection object is equal to CONN, which we have already created above. Index is equal to false. So index is equal to false. What it does is it indicates that the data frame's index should not be written as a separate column in the table. For example, here this 0 and this 1. So we have a separate index here, right? For example, if I show you top 5 rows, so 0, 1, 2, 3, 4, right? So these are the indexes. I do not want these indexes to be represented as a separate column in SQL table. That is why I'm writing index is equal to false. Then if exists, so if any table exists by this name, orders_data, then replace it. If you want to append the data, in many cases we have to append the data, let's say daily basis or monthly basis or weekly basis. If we have to update the data, add the data, then we can write append instead of replace, right? So if I just run this command, it will take a while to run it, and once it is completed, let me just pause that, and we will return when it's done. So now it is done, right? And let me check in this project database in this server whether a table called orders_data is there or not, right? So when I go to here, I click refresh, right? And we go to the project database, and when I expand the table section, we must have a table called orders_data, right? So if I show you the data, select star from orders_data, right? So we will have the same data as we already have in the df1 data frame, right? So that's how we can export our data from Python pandas to SQL Server. That I hope that's clear. Now, if we see, let's move ahead in pandas, and we will do some more analysis and generate some insights right here, right? So let us we have a set of some questions. Let us solve them one by one. So these questions are ranging from basic to intermediate level, and I hope you will definitely understand the explanation. So the first question is, find the top 10 highest profit generating products. Correct. So what I will do first, what I have to do, I have to see the profit of each product, profit in each product, and we have to sort the data in descending order and then take the top 10. So there are 3 steps. So first I have to create a group of the products and see the sum of profit. So for example, let's say there is a product ID this, and it must be in different orders, right? It might be sold in different orders. So what I have to see, I have to take the sum of profit, total profit actually, right? Sum of total profit for this product in any orders, in all the orders actually. And then I will get the total profit or for each product, then sort the data in descending order and then take the top 10. So first I'm creating, let us understand it step by step. First I'm creating a group, right, of all the products, right, product by the column product ID. Then what I will do, I will take the sum of total profit. Let me show you this much part. So if I run this much part, you will see that for each product, we have the total profit column. So this is the sum of all the total profit. Let's say this product was ordered in 10 different orders, So the total profit was this. This product, let's say, was ordered in 7 orders. The total profit made through this product is this, right? So that's how it is interpreted. Then what I will do, I will reset the index and sort the values in descending order of total profit. So then I'm doing it again, sort the values by is equal to total profit. So sort values is a function in pandas which helps to order the data, sort the data either in ascending or in descending order. So currently I want to sort it in descending order, so I'm writing ascending is equal to false. So if I explain it to you again, df1.group by, first I'm creating a group of each product, then I'm taking the sum of total profits, and then I'm sorting the data in descending order by total profit column, right? So if I show you this much part, like this, it looks like this, but here we can see that product ID is like an index of this data frame. So I will reset the index so that the product ID becomes the actual absolute column. So again, the same line till here, then I'm resetting the index, right? So if I remove this part, resetting the index, we will have a data frame of all this, right? Or all the numerical columns. but I only want to see the total profit column. So I will just see the total profit column. And when I run it, execute this line, we will have the total profit for each product, and that is sorted in descending order. Correct? So that's how we can calculate the total profit, top 10 products with total profit. Correct? And if I want to see the top 10, we can just see like, dot head 10. It will give us the top 10 rows like this. Correct? And if I want to see the products also, so instead of total profit, we can select the two columns right here. The product ID, right? PRODUCTID. Okay, we have to put it in actually two brackets, square bracket, because we are selecting more than one column, right? Give me a second. Let me just debug. Okay, so the column name is wrong actually, right? So product ID in ID D is a small, and I have written it in capital letters by mistake. So let me just sort it. And so we can see the all the products, top 10 products with the highest profit. So these are the products which are benefiting the company the most, right? So see, there can be multiple angles. We can see the top 10 products according to the revenue. So now you can do it as an exercise, right? So you can see the top 10 products according to the selling quantity or the selling price. We have calculated according to the total profit, right? So there can be different angles to see top 10 products. Correct? So this is how we can see the top 10 products according to the profit. Now, if we move forward, then it is asked that to create a column for the total sales value of each order. Correct? So we already have a column for unit selling price, right? And we have a column for quantity. What we can do is we can just multiply them to get the total sale price. So for example, in an order, let's say in order ID 1, this product was sold and the quantity was 2 and the unit selling price was this. So if we multiply 2 into 254.8, we will get the total sale value of this order. So that is exactly what I'm doing here. DF1 of total sale, that means I'm creating a new column called total sale, is equal to DF1 of unit selling price, and then I'm multiplying it by DF1 of quantity. Correct? So that's how we get total order sales value of each order. And this is the new column which is created. Correct? I hope that makes sense. That makes sense. And if you have any doubt, if you're not able to understand any of these things, just let me know in the comment section and we can discuss and solve them. Then it is asked to write a Python code to list all the distinct cities where the orders have been shipped. Okay, that's again a very good insight for the company, because they obviously would like to understand in which areas, in which cities are they present, are they able to deliver their order, so that they can take business driven decisions. Okay, we have to expand in these and these cities. Correct. So if I show you the top one row only in the data set, we have a column for city here. You see? So to get the distinct values in city, to get the unique values in from any column in Python, pandas, we have a inbuilt function called unique. So df of city, right, dot unique, it will give us all the unique values like this. But if you want to see the number of unique values, number of different cities, so if we have a function called n unique. So if I execute it, you will see that we have a 531 different cities. So instead of n unique, I'm using unique to get the list, actually to get all the cities where we are present as a business. Okay, so that's how the question flows. And moving forward, we have to calculate the total selling price and profit for all the orders. So I think we have already done that. We have already total profit and the total selling price of all the products. Right. Previously, we just have calculated that like this, total selling price. Right. Moving forward, and then we have the next question as find all the orders from the technology category that were shipped using the second class ship mode. Okay, so if we see the data frame here, df1 dot head 2, right? So it will be like this. Okay, so we have all these columns. So you can see that to get the second class ship mode, we have to use this column ship mode, and to get the technology category, we have to use the column of tech category, right? So these two columns are to be used, and we have to take the and condition. We have to put the and condition because it is asked that we have to see the technology category as well as the second class ship mode. So what I can write is like this. So let me just first break it down for you from here. Yeah, till here. So see, first what we can do is we can see the orders for all the technology categories like this. df1 on in bracket, when the value is technology, just give me all the orders. So these are all the orders where the category is technology. After this, we have to put a condition for, ship a second class. So what I can do is I can also put an and condition here like this, and inside a small bracket we can put the another condition. df1 of shipping mode is equal to second class. So remember, always whenever we use double equal to, it is for comparison operator, right? And I have to put the first condition into the bracket. So df1 category should be technology and the ship mode should be second class. So if we see this, we have all the orders where the category is technology and the shipping mode is second class, right? So I hope you are able to understand this. So that's the second question. Then we have the next question is find the average order value. So to calculate the average order value, so average order value will give us the overall picture of the company, right? That, okay, this is the average order value. This is the average ticket size of our order. So that means that sum of total selling price divided by the total number of orders. So for that, we can easily do that. Let me just see first what is the data frame looks like. df1.head2. Okay, so we have a column for total sale, unit profit, total price, and this. Yeah. So I think here it is mentioned wrong. Order value. What we can do is we can take the total sale column. So to calculate the total, average order value. So total sale and np.mean. So here I'm using NumPy libraries of Python, right? So NumPy libraries for mathematical conditions, numerical Python actually. So for mathematical operations, you can easily use this library. So np.mean, np that is NumPy library dot mean to calculate the average df1 of total sale column. So just give me the average of this column, and this is 1108.59. So this is the approximate average order value of each orders, right, for the company. So that's again a very good insight. The next question is find the city with the highest total quantity of the product ordered. Okay, so that's again a very similar question. We have to get the cities with the total highest to total quantities of the product ordered. So again, let us break it down. First, we can group the data according to the city, and then do the aggregation. That means we can group the data by city and then find the sum of total quantities. So for example, if we see the data set df1.head2, we have a column of city and then we have a column of quantity. So we can just group the data according to city and find the total quantities ordered in each city. So see, df1.group by city, that will create a group according to the city, each cities, right? Then dot sum of unit selling price quantity. That means I'm doing the sum according to the quantity and taking out the column of. But I think we have to put quantity here. We have to take the sum of quantity, and then I'm taking out the column of quantity. So let us break it down and understand it very carefully. So I have to write quantity here, right? So df1.group by city and give me the sum of quantities in each city, right? So for example, in city Aberdeen, the quantity of the products ordered or total orders are 3, correct? So I will just extract my useful column, that is quantity. Rest all the other columns are not useful for me. So now this is the actual picture. After that, I will do the reset index. So why reset index? So that I can, instead of city being an index, I can create a data frame with normal indexes and city and quantity as a different columns, correct? Now, so this is what we are getting. Now we have to sort the data in descending order of quantity. So sort underscore values, this is the function in Panda which helps us to order the data in ascending or descending order, correct? So sort underscore values by is equal to quantity. So we have to sort the data by quantity, right? This is the thing. And then ascending is equal to false because we have to sort the data in descending order. Correct? So now this is the overall output. So we see that the New York City has the highest number of orders, followed by Los Angeles, followed by this city, and then San Francisco and Seattle and so on. Correct? So if they want to see the top 10 or top 5, so you can just use the head function. So I hope this is clear, right? So to see the total cities with the highest quantity of the products of orders, correct? So that's the thing. After that, if we move forward, then the next question is rank the orders in each region by quantity in descending order. Okay, so above we have done according to the city. Now we have to do, we also have to take into consideration the region. So it's a very simple thing, right? What are we doing is we are just sorting the data by region and quantity. So priority will be given to region. After that, quantity will be given priority, and ascending is equal to true, comma false in a bracket. That means sort the data in ascending order of region and descending order of quantity. And I'm taking only 3 columns into consideration, that is order ID, region, and quantity, because I only have to see those 3 columns. So for example, it means in order ID 661, it was placed in central region and the total quantity of that order was 14. So followed by in central region, followed by 1046 order ID, followed by 7388 order ID, and so on. And it will be sorted according to the region in ascending order and quantity in descending order, right? So that is how we can rank the orders in each region by quantity in descending order, correct? So then the next question is, list all the orders placed in the first quarter of any year, January to March, including the total cost for these orders. Okay, that's again a very wonderful question. We can do it in multiple ways actually, right? So we have to list all the orders placed in the first quarter, okay, of any year. So for example, let's say the company continues to work from 2020. So 2020, 2021, 2022, and 2023, 24. So we have to see get the sales of first quarter in each year. So what I can do, see, currently I have only a column of order date, right? In DF1, if we see the overall data frame, so we have a column for order date here. Yeah, like this, right? And we have already converted it into date time data type. Now what we can do is we can just create another column for the month. How we can do that is df1 month is equal to df1 order date dot dt dot month. So this is a function in pandas which helps us to calculate the month out of a date. For example, if I just show you this much part, so it will give us the column for the month number. So for example, the first value of the order date will be 2023-0301, that is March. So see, it is giving 03, that is March. Second is of 8th month, and so on. Correct. So I'm just creating a new column of month. Then I'm again I can also similarly calculate the order column for year dot dt dot year if needed. Correct. Then what we can do is df1 dot month is in an operator in pandas which helps us to get the values from that column. So if the value of the month column lies in 1 or 2 or 3, that is the first quarter of any year, just give me those rows, right? So it is giving me all the rows where the month is 1, 2, or 3. Correct. So that's how we can calculate the sum of the total sales for each order. Alternatively, what we can do is we also have a function of quarter, right? So similarly, we can create a column for quarter. df1 quarter is equal to df1 of order date dot dt dot quarter. It will help us to calculate the quarter number from that order date. Correct. And then what we can do is, so if I have to, okay, let me just remove this. And if I show you the data frame now, so we have a column for quarter. So first month was 3, that is the quarter 1. This is month 8, that is the quarter 3. So and that's how we can do that, right? And yeah, so now we can just calculate the sum of total sales where the quarter value is 3. Sorry, quarter value is 1. Right. So currently in the question, it was only asked to list the orders placed in the first quarter of any year. But let's say if they also ask us to calculate the total amount of orders placed, right? So what we can do, we can just move a step ahead. I'll just create a column for year. df1 of year is equal to df1 of order date dot dt dot year, right? That's how it will give us the column for year. Then what I can do is I can just group the data by year and the quarter and take the sum of the total sales column and reset the index, right? So this is what it will give me, yearly, quarterly sales, right? So for example, in 2022, there are 4 quarters and these are the total sales. In 2023, the 4 quarters sales are there. And then I can just filter the data for quarter 1 from both the years. So I'll put into a temporary data frame. And then from the temporary data frame, I'm selecting the quarter 1. Right. So this is the total sale for quarter 1 and this is the total sale for quarter 2. Similarly, as an exercise, what you can do is you can take the total amount of orders, number of orders placed in each quarter, right? So you can do this as an exercise and post your solution in the comment section. And if there is any doubt, just let me know. Correct. So this is how we can perform this analysis. After that, what we are asked is to find the top 10 highest profit generating products. Okay. Again, that's a very simple question. Right. Again, I have to do what I have to do is I have to just group the data by product and see the total profit. Correct. So what I can do is df1.group by product ID, taking the sum of total profit, and I'm just extracting that column from the data frame, resetting the index so that the product ID does not become the index. I have already done it in the previous question, so I'm not segregating different steps, but you can select this part and run the output, see the output. Then you can take this much part and see the output. Then till here, see the output. Then you can do the reset index and see the output. So you will understand and observe each difference of each steps. Right. So I'm resetting the index. After resetting the index, I will sort the data by total profit in descending order. That's how I will see that all the products with the total profit in descending order. But they are asking me to show the top 10 highest profit generating products. So I can just put so since it is again a data frame, in a data frame, we can see the top 10 rows by head 10. Right. So this is how it will give me top 10 highest profit generating products. Then top 3 highest selling products in each region. Okay. So see, here we had to group the data only by product ID. Now they're asking us to see the top 3 highest selling products in each region also. So we have to take into consideration 2 things. First is region and second is the quantity. So nothing different. We just have to consider both the things. That means we have to group the data by region as well as the product ID according to the quantity. Correct? Highest selling products. We have to group the data by region as well as the products. So what I'm going to do is df1.group by is group by. I have to do group by region and product ID, taking the sum of quantity and just taking the quantity column out of that, resetting the index so that the region and the product ID does not become the index. Let me just show you the breakup also. So if I take it only till here, let's say only till here. Yeah. Copy that, paste it here. So you see that region and the product ID are working like an index in this data frame, but I do not want that. That is why I put reset index, right? So first out of this, I will just take the quantity column. Let me just show you step by step. If I only because only the region, product ID and the quantity column is of my use, otherwise no column is of my use, right? So I'm just taking these 3 columns, but see here region and product ID are like index. So I will just do reset index dot reset index. Reset index. Yeah. So now index is 0, 1, 2, 3 and so on. And the region and product ID are working like a column in this data frame. Correct. And then sort the data by region in ascending order and quantity in descending order. That's what I'm doing here. And if I show you the output, I'm placing this into X data frame, and this is the X data frame. So in the central region, this product was ordered the most. In central region, followed by this product, second top orders quantity, right? So this is again a very good insight for the business management, that they can very clearly observe that, okay, in this region, this product is highly selling, but this product is not performing well. So that is according to that, they can take business driven decisions. Okay, we have to put more offers, give more discounts on these products. And for the inventory management, we have to put this product, deliver this product fast and so on, to make the user experience better, and similar data driven decisions. That's how we can contribute to the success of an organization as a data analyst or as a business analyst, right? So I hope that's clear till here, right? And then we have some more questions. You can just solve them, like total sale in each region. Again, a very similar thing. We have to group the data by region and take the sum of total sales order, total sales column, right? So we can see in central region, I think the sale is highest, right? We can also sort the data. So sort underscore values by which column? We have to sort the data by total sales column to total underscore sale, right? And sort the data in descending order. Ascending is equal to false, right? So see, okay, we can see that in the west region, the sale is highest, followed by east, central, and then south region, right? So this is how the company is performing in each region. Then we have again similar questions like find the top 5 highest selling products in each region according to the sales. Again, a very similar thing. We have to take product and the region into consideration according to the total sale. Here in above we have done according to the quantity. See, quantity. But here we have to see according to the total sales. That is just difference, just a very small difference, right? So now we can solve such questions, I think, right? Do this as an exercise, practice them. Let us know in case of any doubts. Then there is again a very interesting question. Find the month over month growth comparison for the year 2022 and 2023. For example, we have to compare the sales in January 2022 and January 2023, right? So that's again a very easy question. Let us solve, right? So to solve this question, first let us see the data frame. Okay, in this in our data frame DF1, we have these column. We have already calculated the month and the year column right here. So first, what I will do, I will just group the data by month and year. Then I will see the sum of total sales, right? Because we have to compare the sum according to each month, compare it, right? So we have now see, we have month and year as the index and total sale here. So I do not want it like this. I just want the total sale column because that is only of my use. So I will just, out of this, I will just extract the total sale column. It will come like this. Then I will reset the index to get the actual data frame. And I am putting it into a data frame, temporary data frame called A. So now this is my overall data. And now what I have to do, so see, in 2022, the January month, this was the sale. And in January month, 2023, this was the sale. Now I just want to put it into a pivot format. Like for example, the year should be in the columns, total sale should be in the values, and the month should be like index, right? So there is again an inbuilt function in pandas called pivot table. What we can do is a dot pivot table. What is a? A is this temporary data frame, correct? So a dot pivot table, I want month as index, columns as year, right? So there will be two columns in the final pivot table. Column 1 is for the year 2022, column 2 is for the year 2023. And what should be the values inside those columns? Total sale. And after the aggregation function of sum. So if I show you this much part, you will see that, okay, we have year 2022 and 2023 and month. So for the January month, this was the sale in 2022 and this was the sale in 2023. That's how we can compare. After this, since we have already got a data frame, we can just reset the index so that the month column should not be the index, right? So after resetting the index will become 0, 1, 2, 3, 4, 5, 6, and 11, 12, and month will become like this, and these are the year. Okay. After this, we can calculate the difference in sales. That's how we will understand, okay, in the previous month, January sale was high, but February sale was low. January sale was low in 2023, and so on. After that, we can also calculate the percentage of difference. And again, I'll ask you to do this as an exercise and post your solution in the comment section so that we can understand, okay, people are actually solving and just not watching the video, because watching this video will not help you. Doing this will help you only, right? So year on year growth, if you want to see, then we can just calculate the difference between these two columns by putting a minus sign right here, right? So I think now till here, you guys are clear with all the questions, right? And then we can, we have already seen how to take the data from data frame to SQL, and we can do vice versa also. We can also take read the data from SQL Server into Python. Again, there are two methods for that: Windows authentication, and I think the second one is SQL Server authentication. I'm using the Windows authentication right here, and I'm using the PyODBC library, right? So what PyODBC library does is, it helps us to create connection between SQL Server and Python, right? So again, I'm creating a connection object, pyodbc.connect. Here I'm giving the driver name. Here I'm giving the server name. Here I'm giving the, okay, trusted connection is yes, so that they do not ask password for anything. And the database is project. So I want to read data from this database. Okay. So after as soon as I can build the connection, I can just write a simple SQL query. Read SQL query, read underscore SQL underscore query is a function in pandas data frame, the pandas library, right? So pd.read underscore SQL query. And this is let's say the SQL query. I have a table called orders data in this project database, right? We have already seen that previously. And I'm just using reading that and by the connection object, right? And putting whatever we get into a data frame. So if I see the data frame after running this will be again whatever we have imported, correct? So this is how we can read the data from SQL Server into Python using PyODBC library. And that's again a very simple step. We just have to give the driver name, we have to give the server name, and we have to give the trusted connection yes and database, correct? So that's how we can get this. And okay, so if you are wondering how do I get this, driver, right? So you just go to your system and search for ODBC, correct? ODBC data sources 32 bits, right? In your might be 64 bit. So just open it, you will get the drivers, whatever connections you have in there, you will get the SQL Server right here in this option, and you just copy the driver from here. This is the driver column, correct? So I hope you understand. So that's all about the Python analysis. Now let us quickly move to SQL part, and we will do all the similar analysis in SQL Server. So I'm doing this just to give you an understanding of SQL as well as Python, right? And I hope it will really be a great idea to learn both of them hand in hand, so that you can understand, okay, this is how do we group the data in SQL, and this is how do we group the data in Python. This is how do we filter the data in SQL, and this is how do we filter the data in Python, and so on, correct? So I have created this project from initially. So I just created a database called project. I'm using that project database, and I have already imported the data. We have seen it previously in this video, correct? But let's say if you have not imported the data, if you do not want to import this data from Python, so what you can do, you can just go read it directly from SQL, CSV to SQL Server. How we can do that is, we can just go to the database project, right click on it. You will have an option of task. In the task, we have to select the import flat file to read the CSV file. This is an introductory message. Next, it is asking us to browse the file, right? So I will just browse the file from my system. So where is that file? In Python plus SQL project, this orders underscore data.csv. I'll open it, and the new table name. So let's say I rename it as orders underscore data set, and the schema will be DBO only. Click next. It will preview the data. It will help us to see the top 50 rows of the data, right? So we just to understand, okay, this is the data which is being imported. Click next, and it is the column of modifying the column. So let's say in our column, in our table, we have order ID as the primary key. So we can just put it as the primary key if it is, right? If not, you can just, you do not need to do this. And if any, in any column, if there is any null value, we can put the checkbox here. So for example, I think in our column table in ship mode, we have some null values, I think, right? So I'm just putting it as allow nulls. Click next. So this is the summary information. In this server, in this database, in this table, this file will be imported. Click finish, right? So let us see how it happens. It is doing, it is in progress. Yeah, so it is done, operation complete, and our insertion of the data into SQL Server is done. Let me close it and go to SQL Server again. And if I refresh it here, right, so we will see that in the table section, we have called order underscore dataset, right? So actually I have done it 2 times. So it is like this. So if I see the table, select a star from orders underscore dataset, execute it. No, okay, so it was not successful. This is successful. Order underscore dataset. Yeah, right. So we see that 9994 total rows are imported into SQL Server, and now we have to do analysis on this table only. Order underscore dataset, right? So let us move on and see the questions. So the first question, which we already solved in Pandas, was write a SQL query to list all the distinct cities where the orders have been shipped, right? So it will very simple. It is in SQL. That is like the command is like select distinct city from orders data, because we already have a column of city in the table. So if I write it like this, so these are the cities. So if you remember, there was 531 cities in Pandas also. So we have again getting the same row. So that is how we do data validation. When we write the queries into different tools, and we can validate their output. Second thing was that calculate the total selling price and profit for all the orders. Okay, so we have to do the 2 things simultaneously. Let us see the original data set first here. Right, order underscore datasets. Right, actually, so see, I'm going to use orders underscore data because this is the table which I already have in my system, and it contains the same data. So let me just show you quickly so that there is no confusion, right? So 9994 rows in orders underscore data. I have already written the queries by this table, so I'm going to use it only, right? So see, in this table we already have a column of quantity and the unit selling price. So if I have to get the total selling price, I just need to multiply these 2 columns, quantity and unit selling price. So that is what I'm doing here. Select order ID, comma, sum of quantity multiplied by unit price. So first multiply this and this and give me the total sum. So let's say if this order is in multiple places, so it will just give me the sum of quantity into unit selling price for each order. And I'm giving an alias called total selling price to this column. Then I'm multiplying quantity and unit profit, right? And taking the sum of it to get the total profit in 2 decimal places. So I'm casting the data, changing the data type, right, as decimal 10,2, that means total 10 digits and up to 2 decimal places as total profit as total profit only, right, from orders underscore data, group by order ID, group by order ID only, not total profit, and order by total profit descending. So if I want to sort the data in descending order of profit, otherwise I can also sort it in total selling price also, right? So that's how it works. So we are doing nothing. We're just taking the sum of quantity multiplied by unit selling price and sum of quantity multiplied by unit profit to get the total selling price as well as the total profit in each order, right? So that's how it works. Now let's move on to the next question. Okay, I hope you are understanding this, but even if there is any doubt, you're facing any issue anywhere, just put me in the comments and I will definitely reply to it, right? So the next question says, write a query to find all the orders from the technology category that were shipped using the second class ship mode. Okay, so we just have to filter the data from using 2 columns. Or if I see the original table, so we have a column of ship mode. In this ship mode, the category should be second class, right? And we also have a column of category of the product ship, and it should be technology. So what I'm doing is I'm just taking order ID comma order date. You can also take all the columns by putting star, right? So select a star or select whatever columns you need. Select order ID comma order date from the table where category. So in Excel when we use filter, it is very similar to use where clause in SQL, right? So where category is equal to technology, and just focus on it here because we have to put both the conditions together. So both the conditions should be satisfied. So category should be technology and shipping mode should be second class, right? So we have to get the exact value from here, right? There should not be any spelling mistake. Just focus on that. Okay. So if I execute it, these are the orders. 366 orders are there where the category is technology and ship mode is second class. I can also validate this point, right? So once I go to here, and we had the question of this. Just let me see. Yeah. So I got this question. Find all the orders from the technology that were shipped using second class, right? So if we run this query and see the output, there are 366 rows on, right? And that is what exactly we are getting here. You can see at the top, right bottom, correct? So that's the next question. Let's move on to the next question. Write a query to find the average order value. Again, that's very simple because we already have a column of, let me just see. Okay, so here we do not have a column of total sale. So what I can do, I can just multiply the quantity by the, just give me a second, orders underscore data. Yeah, we have this table which I'm using, right? So we already have a column of unit selling price and quantity. So we can just multiply it to get the total sale and take the average of it. Correct? That's very simple again. So see, I'm multiplying the quantity and unit selling price to get the total order value. Then I'm taking the average of this. After taking average, I'm casting it as decimal up to 2 decimal places. That's how it works to calculate the total average order value. If I execute it, it will be a single digit, right? Why it is a single digit? Because I'm taking the average of whole column on. I'm not taking order wise, I'm not taking city wise, I'm not taking region wise, I'm taking overall. But you can also solve it by order wise, or maybe city wise, or maybe region wise, or maybe category of product wise, right? So like then you have to just group the data by that column, right? Just take it as an exercise and try to solve it. Find the city with the highest total quantity of the product ordered. Okay, that's again very good. So since it is asking for highest, that is why I'm using top one. If you are using MySQL database, then you have to use limit function instead of top one. That's a very difference between SQL Server and MySQL. Correct. So I'm just taking city comma sum of quantity because I have to take the city according to the quantity of the products ordered. So I'm taking the sum of quantity. That will give me the total quantity. Group the data by city and order the data by total quantity. Why total quantity? I'm sorting it in descending order so that the city which is having the highest quantity, highest total quantity ordered, it will come on the top, and then from that I'm just taking top one. So it will give me the highest city city with the highest total quantity ordered, and that is exactly which we saw in Pandas also, New York City, right? 3417 quantity of orders were placed. right? So let's move on to the next question. Using a window function to rank the orders in each region by quantity in descending order. Okay. Right? So to solve this question, I'm just taking order ID, comma region, comma quantity as total quantity. And I'm using dense rank window function. Why dense rank window function? Because let's say there are two orders which are having same quantities, correct? So same quantities. Rank will skip for the next order, but dense rank will not skip for the next order. That's why I'm using dense rank. So the orders which are having the highest quantity will be given dense rank 1. The next order will be given dense rank 2. It will not skip, right? That is why I prefer to use dense rank, and I'm just ordering the data. So I'm just running it. So dense rank over does two things. It partitions the data and sorts the data. So I have to partition the data according to the region, because in the question it is asked to use a window function to rank the orders in each region. That is why I'm doing the partition by region order, right? And sorting the data by quantity in descending order. That is why I'm sorting order by quantity in descending order. That is why I'm sorting the data in descending order of quantity and giving the column name as RNK from orders data, order by, that is, I think, not needed. If I run it only, that is how we are getting. So in central region, this order ID was having the highest quantity. Similarly, all these orders are having the same quantity. That is why all of them are giving dense rank 1. For the next order in the same region, the rank is assigned, a dense rank is assigned to 2. If I had used rank, it will not be 2, right? It must skip those many rows. So I hope you understand the difference between rank and dense rank. Otherwise, you can check window function video on my channel. That will help you a lot. Okay, so we have ranked the data according to quantity ordered in each region. I hope that makes sense and you are able to understand it. Practice it and just let me know for your doubts. Then the next question says, write a SQL query to list all the orders placed in the first quarter of any year, right? We have already done the same thing. Again, we are just going to do the same thing. So see, in SQL, to extract month from a date. Okay, so let me show you the whole data first. So you see, we have a column only for date. We do not have a column for month. First quarter basically means the month 1, 2, and 3. So to get the month, what I can do is I can write it like this. Select, let's say, order ID. Okay, it will be inside a order inside a square bracket because there is a space between the column name, comma, order date. Okay, it will again be in a order, again in a square bracket, right? Order date, not underscore, just this, comma. If I write it like this, month of, in bracket, order date. So you will see the output. It will give us the month from each column, correct? From each order date, month from orders underscore data. That's all. See, so first order was 1st March 2023 and it is giving month as 3. 15/8/2023, it is giving month as 8. So this is how do we extract month from a date in SQL Server, correct? This function might differ for different databases. Just stay alert. So I'm just doing select order ID, comma, quantity multiplied by unit selling price and taking sum of that to get the total order value from orders data, where month of order date in 1, 2, 3, right? Because I only have to take the first quarter data, and the first quarter data basically means month should be 1 or 2 or 3. That's all. And then grouping the data by order ID to get the total order value for each order, and sorting the data by total order value in descending order. If I execute it, so this is the total order value for each orders which are placed in any quarters in first quarter of any year. Okay, that's the thing. If they ask you to put one more condition, like let's say year 2022 only, then we must have put one more condition, and year of order date is equal to 2022 or 23, whatever is asked. Okay, so I hope that is clear till here. Let's move on to the next question. Find the top 10 highest profit generating products. Okay, that's again a very interesting question. Very easy actually, right? So again, what I will do is I will just do it, select product ID, comma, sum of total profit. Okay, let's see the original table. So I will start from orders data, right? So we already have a column of total profit and the quantity. So by multiplying these two, okay, so oh no, unit profit and quantity, by multiplying these two, I have already calculated total profit. So what I will do is I will just take the product ID and the total profit, sum of total profit as profit, from the tables ordered underscore data, group by group by product ID, because I have to calculate the total profit according to each product ID, right? Group by product ID, order by profit column in descending order. Why I can use the column name here? Because if we see the order of execution in SQL, order by clause is run executed after select statement. That is why when this column is created in the select statement, we can use it in order by clause. If that is not clear, you can just check out another video on my channel, which explains us about the order of execution in SQL, right? And why I'm taking top 10, because they're asking top 10. Now there is a catch. Sometimes in the interview, they also ask us to solve the question without using top or limit function. Then we can take the help of window function. What I can do is I can just calculate the product ID and the sum of total profit and give the rank to the data, to the products, right? And then take data from that temporary table from 1 to 10. I've given the logic. I've also solved it here, but you just try it first yourself. I'm just using CT and I'm putting this temporary data into CT. And then from that CT, I'm filtering the data where the rank is less than equal to 10. Okay, so better it will be if I use top 10 highest. Yeah, better it will be if I use dense rank. Again, for the same reason, right? Or even we can use row number also. That's again a similar thing. Similar in this particular situation, they both will produce similar output. Okay, so that's the thing. Now try to solve it yourself also. Otherwise, you can see the solution from here. Now, the next question could be, okay, yeah, they can also ask you for the top N products according to the revenue or sale. Here we have calculated according to the total profit, but they can also ask you according to the total revenue generated, total quantity ordered, total sales value, right? So just be prepared for that and try to do it as an exercise. Post your solutions in the comment section so that we can understand, right? That's the thing. Okay, now the next question is find the top 3 highest selling products in each region. Okay, again, very similar thing. We just have to group the data by region as well as the product. The very similar approach which we have already taken in Pandas. So what we will do is we will select the region, product ID, because we have to see top highest selling products in each region. So region and the product ID, quantity multiplied by unit price, and I'm taking sum of it to get the total order value of this product in this region, right? And then I'm using window function, row number over partition by region, because I have to get the data according to each region. So I'm partitioning the data by region only, sorting the data by order value, sum of quantity into unit selling price, right? In descending order, sorting the data in descending order as Rn. I'm giving the alias as Rn from orders data, grouping the data by region and product ID, because I have to see for all the products in each region. That is, I have to group the data by this. So if I show you this much data, it is something like this. So in central region, this product total sale value was this. In let's say in any other region, for example, let's say in east region, this product was sold for this much value, right? That's the thing. So since these are all in the east region, right? I hope you are able to understand this. And these are the row numbers given to them, right? And then what I have to see for top 3 highest selling products, I'm just taking select a star from CT where row number is less than equal to 3. That's how we will get top 3 highest selling products according to the sale value in each region. Now do this again as an exercise. Instead of total sales value, try to achieve it using total profit. Top 3 highest selling products in each region according to the profit generated. Okay, so I hope that makes sense and you will be able to do that. Okay, then the next question is find the month over month growth comparison for the year 2022 and 2023. Okay, that for this question we used pivot concept in Pandas, but let us now see how to do it in SQL Server. What I'm doing is I'm just again extracting the year from the order date as order year, extracting the month from order date as order month, and taking the sum of quantity multiplied by unit selling price as a total sales. From this, group the data by year and month. So what we will get is we will get the monthly yearly sale of each product. Total monthly and yearly sale in each month. Then what I have to do is I have to do a compare actually, right? So for example, for 2023, the total sales value in 9th month and compared to order year 2022. So what I'm doing is I'm taking order month as the first column, and then I'm taking the using the case expression. Case when order year is equal to 2022. So whenever this column value is equal to 2022, then take the sales, else 0, and is used to end the case expression, and rounding it off to two decimal places as sales 2022. Basically, I'm doing the pivot thing, but with using case expression. That means I'll take this column as the first column, and from this column, whenever the value is 2022, take this value from the sales column and put it here. And for the next column, I'm taking again very similar thing, but for the year 2023. So what it will create? It will create 3 columns. First column for order month, second column for sales 2022, third column for sales 2023. And the values will be sales, the value in the sales column. So if I show you the overall, this is the output. So for January in 2023, this was the sales, and for 2023, this was the sales. For April month, sales in 2022 was this, and 23 was this. Now there is an exercise for you guys. I have taken here the month number 1, 2, 3, 4, 5, 6. But there is also a function in SQL, right? In MySQL, it is called month name. For SQL Server, you have to look out, right? And by using which we can, instead of giving it as month number, we can give the exact month name, like January, February, March, and April, right? So try to do that. And now, since we are able to get this 2023 and 2022 sales, now we can also calculate the difference between them and also the percentage difference between them. So that's an exercise for you guys. Post your solution in the comment section. Okay. Now the next question is, for each category, which month had the highest sale? Okay. Then again, the very similar approach. Here, what we have to do, we have to partition the data. We will use row number, and we will partition the data according to the category of the product. Okay. And highest sale. So that is again, to get the high sales, we will just multiply the quantity by unit selling price and sort the data in descending order. And then we will take for highest sales, right? So we will just take where the row number is equal to 1. So again, I'm doing the same thing, category. And then I'm taking the order year month. Why? Because they are asking for the which month had the highest sale, right? So this will give us the year and month both. Sum of quantity into unit selling price as a total sales, and I'm using the window function, partitioning the data by category and sorting the data by sales value. Correct? So if I show you this much part, we will get the monthly sale of each category of product. Monthly sales for each category. Correct? Now what we have to do, I'm putting it into a CT, like temporary table, and then I'm selecting the category, order year, month, and the sales from this table where row number is equal to 1. That will give us the highest sales for each, category wise highest sale in each in months. Okay, that's the thing. So if I see for furniture in 8th month and 2023, we did the highest sale. For office supplies category in February 2023, we had done the highest sale, and so on, right? So that's how it flows. I hope you're able to understand this. If there is any doubt, just let me know in the comment section. Okay. And for which subcategory had the highest growth by sales in 2023 as compared to 2022? Find the actually, we have to do the comparison of the sales in year 2023 as compared to 2022. Okay. So that's again a very simple thing. Let me just show the table and discuss the algorithm, and then we will solve. So see, we have to find the according to the subcategory. So we have already a column of subcategory, and then what we will do is we will calculate the yearly sales of each subcategory. The first step will be this, and what I'm doing is in the first CT. So see, select subcategory as sub_category, comma, year of order date as order year, and taking the sales. And again, every time sales is calculated by the same formula, sum of quantity multiplied by unit selling price. And I'm grouping the data by subcategory and the year of order date. So if I show you this much data, now we have calculated the yearly sale of each subcategory, right? Now, the next step would be to do the pivot as we did previously. What we will do is we will take the order year, subcategory, and then we will create 2 different columns for order year 2022, order year 2023, and put the sales value in the column as values. Again, I'm doing the same thing. Select subcategory, comma, case when order year is equal to 2022, put the sales value in the column. When the case when order year is equal to 2023, put the sales value in the sales 2023 column. That is how I am creating 2 different columns. So if I show you these two cities, output of this city, right? So now we have, let's say for example, in accessories category, in 2022, this was the sale, and in 2023, this was the sale. Then again, the next step is very simple. We will just take the difference of that, right? And since it was asking which subcategory is the highest growth, so I will just take the top one, right? Top one. So top one subcategory, comma, sales of 2022, sales in 2023, and taking the difference of them from this CT2 and sorting the data by descending order of difference. That is how we will get the highest growth, right? So in machines category, we had got the highest sales, highest growth in the sales, right? So I hope this question is clear. These are the three steps. First, we will calculate the yearly sales of each subcategory. Then we will take the pivot to compare the values of each subcategory for the year, and then we will take the difference and see the top subcategory according to the difference. Okay, so that was the last question in this series. I hope this project helps you a lot. And to be very honest, trust me on this, if you are able to solve this project in Pandas as well as in SQL, right, in any database, you are very good to go. And this is a very wonderful project which you can put in your resume, on your GitHub, and show to the interviewer as a portfolio project, right? So please try to solve this project very honestly. Whatever exercises we have discussed during the video, try to solve them. Put your solutions in the comment section, right? And create a very wonderful report of this of the project and show to the interviewer, right? So this project is very helpful for, again, aspiring data analysts, data engineers, or who are working, who are having an year experience of, let's say, 1 or 2 years, who want to strengthen their portfolio, resume, and practice by doing hands-on practice, right? So I hope it helps. Please, if this video, if this project helps you in any way, do consider subscribing our YouTube channel, the Dataholics. We are all, let's stay connected on different social platforms like Instagram, LinkedIn, and all. Right? You can also DM me or on Instagram for any other queries, any other projects. You can put down your comments if you want me to solve any other interview question or like this. Right? Visit our channel for more content on SQL, Python, data analysis, business analyst. Right? And for anything, just put down us in comment. Put down that in comment, and we will definitely revert back. Right? Thank you so much, and I hope it helps. Consider YouTube channel. Thank you.